Hello viewers, in today's class we are going to discuss yet another important and conceptual problem from definite integrals involving Signum function, right? So here we have to evaluate this integral and we are given the integral from 0 to 2 Signum of 4 minus 3x divided by 3x plus 4, right? So here we'll calculate the value of this integral involving Signum function, right? So let us call this integral as I, right? Now here in order to evaluate such type of integrals involving Signum function or absolute value function or greatest integer function, what we basically do, we make use of the definition of these functions, right? So here since the Signum function is involved, so what we will do, we'll first take the definition of Signum function. Now let us define Signum function. See, Signum of say y is equal to plus 1 whenever y is greater than 0, and Signum of y is equal to 0 whenever y is equal to 0, and Signum of y is equal to minus 1 whenever y is less than 0, right? So this is the standard definition of Signum function, and this definition speaks a lot, right? See here, Signum of y will always take plus 1 value whenever y is a positive number, that is y is greater than 0, and Signum of y is equal to 0 whenever y is 0. It means Signum of 0 is equal to 0, and Signum of y will take always take a negative 1 value whenever y is less than 0, right? So for all negative numbers, Signum of y will take minus 1 value, right? So now we'll apply this definition to this function. See, here we have a Signum of 4 minus 3x, right? So if we compare this expression with this one, we see that we can replace y by 4 minus 3x, right? So Signum of 4 minus 3x is equal to plus 1 whenever 4 minus 3x is greater than 0, and Signum of 4 minus 3x is 0 whenever 4 minus 3x is equal to 0, and Signum of 4 minus 3x is equal to minus 1 whenever 4 minus 3x is less than 0, right? So now what we will do, we'll solve these two inequalities along with this equation, right? So 4 minus 3x greater than 0, it implies 4 is greater than 3x, or we can write x is less than 4 over 3, right? And from this equation we'll get 4 is equal to 3x, or we can write x is equal to 4 over 3, and here we can solve this inequality by writing 4 is less than 3x, and it implies that x is greater than 4 over 3, right? So now we can redefine this Signum function, that is Signum of 4 minus 3x is equal to plus 1 whenever x is less than 4 over 3, and Signum of 4 minus 3x is 0 whenever x is equal to 4 by 3, and Signum of 4 minus 3x is equal to minus 1 whenever x is greater than 4 over 3, right? So once we have done all these things, we can come to this integral, and let us first concentrate on the limits, right? So here the lower limit is 0 and the upper limit is 2, right? So here we have 0 and here we have 2, right? And here we can write minus infinity, and here we can write plus infinity. Now the objective of writing these limits on the number line will be clear. See, here we have x is equal to 4 over 3, and 4 over 3 is greater than 1. And see, if we have here 1, then 4 over 3 lies somewhere here, right? So here we have 4 over 3. Now we can remove this one. So here we have 4 over 3. Now see, the first inequality, x is less than 4 over 3, right? So in this part, right, so in this part, that is from minus infinity to 4 by 3, we have x less than 4 over 3. So when x is less than 4 over 3, then this signum of 4 minus 3x will take the plus 1 value, right? And when x is equal to 4 over 3, that is this point, then signum of 4 minus 3x will take the value 0. And when x is greater than 4 by 3, right, that is this part, right? So this part, then signum of 4 minus 3x will take the negative 1 value, right? So it means 4 by 3 is the point where we have to break this integral, right? So now this integral I can be written as, the first integral can be written as, or we can write I as I1 plus I2, right? So I1, it goes from, see, the lower limit is 0, right? So we'll go from 0 to 4 by 3. So 0 to 4 by 3, and here we have signum of 4 minus 3x divided by 3x plus 4 dx, right? And I2 is from 4 over 3 to 2, right? So the first integral goes from 0 to 4 by 3, and the second one, it goes from 4 by 3 to 2, right? And we have signum of 4 minus 3x over 3x plus 4, and here we have dx, right? Okay, so now we have these two integrals to solve. So now viewers, this integral I can now be written as, see, the first integral. The first integral goes from 0 to 4 by 3, that is from 0 to 4 by 3, and in the interval 0 to 4 by 3, all the values of x are less than 4 by 3, right? So signum of 4 minus 3x will take the positive 1 value. So here we have 0 to 4 by 3, and for signum of 4 minus 3x will have plus 1 value, and in the denominator we have 3x plus 4 and dx, right? And in the second integral we have 4 by 3 to 2, and signum of 4 minus 3x, see, when we go from 4 by 3 to 2, then all the values of x are greater than 4 by 3, and in that case signum of 4 minus 3x will take the negative 1 value, right? So here we have minus 1, and we have 3x plus 4 dx, right? So now we have two simple integrals to solve. So now we can rewrite these two integrals as 0 to 4 by 3, and we have dx over 3x plus 4, and here we have we can take this negative sign outside, so we have minus 4 by 3 to 2, and we have dx over 3x plus 4, right? And now here we'll apply the rule which says that integral of 1 over, say, ax plus b is equal to 1 over a log of ax plus b, right? So this rule would be applied here. The value of a is 3 and b is 4. This is a standard result in indefinite integrals. And now we have I is equal to 1 over 3. The first one, we have log of 3x plus 4 limits are from 0 to 4 by 3, and the second one is 1 over 3, and we have a log of 3x plus 4, and the limits are from 4 by 3 to 2, right? So now we can simply substitute the limits and we'll take the difference. So we have 1 over 3, and first we'll take 4 over 3 here. So we have log of 3 times 4 over 3. 3 and 3 get cancelled. So we have 4 plus 4, 8. Minus, then we have 0 here. So this is 0 plus 4. So we have 4 here. And then we have minus 1 over 3. And here we have 2, so 3 2s are 6 plus 4, 10. So this is log of 10 minus, we'll have 4 over 3 here, so 3 and 3 get cancelled, 4 plus 4, 8, so we have log of 8, right? So now we have this expression. We can write it as 1 over 3 log 8 over 4, and here we can write 1 over 3 log of 10 over 8, right? Now here we have used the important properties of logarithms. So log of m minus log of n is equal to log of m over n, right? So here we have this expression. Now we can simplify it. 1 over 3 log of 2, because this is 4 2s are 8, and here 2 5s are 2 4s are, so we have minus 1 over 3 a log of 5 over 4, right? And now we can take 1 over 3 common. We have log of 2 minus log of 5 over 4, and again we'll make use of this result to simplify this one. So we have 1 over 3 log 2 and divided by 5 by 4, and now we can write I as 1 over 3 log of 8 over 5, right? So we have the value of this integral as 1 over 3 log of 8 over 5, so which can also be written as log of 8 by 5 raised to 1 over 3. So here we have used the result, that is log of n log m is equal to log of m raised to n, right? So here we get I is equal to log of 8 over 5 raised to 1 over 3, and if we take the cube root of 8, we'll get 2, so we have 2 over 5 raised to 1 over 3, right? And this expression can also be written as I is equal to log of 2 over cube root of 5, right? So viewers, the value of this important integral is log of 2 divided by cube root of 5, and this is how we solve this important problem.